This is my third video lesson on Unit 9. In this lesson, we'll be describing radioactivity. Go to page 11 in the class packet. I first want you to watch a video about whether radiation is dangerous or not. The link to the video will be in the descriptions. Pause the video and resume once you watch the TED video. Learning target. At the end of the lesson, I'll be able to analyze and compare 4 types of radiation. One will be number 3, which will be a junipod based off this lesson. From the video, you should have a basic understanding on what is radiation. To figure out the definitions of these terms, take a moment to read the paragraph on page 11. Once you finish reading, come back to the video. Now let's go over the definitions. Radioactive is an atom with an unstable nucleus. Transmutation is the process of an element changing into a new element. Ionization is the process in which an atom or a molecule gain or lose electrons. If it gains electrons, it becomes a negative ion. If it loses electrons, it becomes a positive ion. Radioisotopes are isotopes of an element that are radioactive. Radiation is the energy released during radioactive decay or energy transmitting as waves or particles. Decay modes are different types of radiations which can be released. There are 3 types: alpha, beta, and gamma. Radioactive decay or radioactivity is when radioisotopes break down into a stable atom or a new element. This releases energy or radiation in the process. Radioactivity is considered a chemical property. Here's a diagram showing a radioactive atom breaking down into particles or radiation. This process is known as radioactive decay or radioactivity. Here's a diagram showing the types of radiation. There's non-ionizing and ionizing radiation. Typically, ionizing radiation is dangerous to humans because it can damage DNA. Now take a moment to watch a video about radioactivity. The link to the video will be in the descriptions. Once you watch the video, resume this one. Learning trick number 1. The nucleus of a radium-226 atom is unstable, which causes the nucleus to spontaneously do what? Pause the video and resume as completed. Since the nucleus of the radium is unstable, it is radioactive. Atoms that are radioactive will spontaneously decay. Answer is choice 3. Nuclear change is when an atom's nucleus changes, therefore becoming a different element or isotope. In a chemical change, bonds are broken and atoms rearrange themselves and form new bonds to make a new substance. As you know, chemical change follows the law of conservation of mass, while nuclear change do not follow the law of conservation of mass. A type of nuclear change is transmutation, which is the conversion of one element or isotope to another. An example of transmutation is converting lead into gold. This is first done by Glenn Seaborg. Radiation is a form of energy that is released when an unstable atom spontaneously decays or transmutes. Although there are many types of radiation, we will only talk about some of the ionizing radiation, which are the decay modes. The decay modes can be found on Table N on your reference table. On Table N, it shows you a list of radioisotopes and the decay modes. The decay modes are the radiation that is released when the radioisotope decays. There are different types of decay modes. You can look on Table O on your reference table to identify them. They are alpha, beta, and gamma decay. Now we're going to complete the table based on Table O. The first type of decay is alpha decay. The radiation release is the alpha particle. This is the symbol of the alpha particle. There are 2 notations for the alpha particle. From Table O, the mass, you have to look at the top number, which is 4, and the charge is the bottom number, which is 2. The alternative name of alpha particle is a helium nucleus. If you look at the notations, you can see the symbol of helium. Alpha particle consists of 2 protons and 2 neutrons. So the mass will be 4, and the charge will be 2, which is based on the 2 protons. So 2 neutrons and 2 protons is the same as a helium nucleus. That is why an alpha particle is also called a helium nucleus. The next type of decay is beta minus decay. The radiation release is a beta particle. The symbol of the beta particle is this. There are two notations. The mass of a beta particle is 0, as you can see from the top number, and the charge is a -1. The alternative name is an electron. You can see it has the symbol of the electron in the notation. The beta particle has the same mass and the same charge as the electron. The next type of decay is the beta plus decay, or positron emission. The radiation release is a positron. The symbol of a positron is beta plus. There are two notations. It has the same mass as a beta particle, but the opposite charge. The alternative name is a positive electron. The last type of decay is a gamma decay. The radiation release is gamma, and here's the symbol of gamma. Here's the notation of gamma radiation. The mass and charge of gamma is 0. An alternative name for gamma is pure energy. Most of this information can be derived from Table O. On the regions, make sure you know how to interpret and use them. Learning check number 2. Positron and beta particles have what? Pause the video and resume as completed. From Table O, they have different charges and the same mass. Choice free. Penetrating power is the ability of each type of radiation to pass through matter. As you can see, each type of radiation can only pass through certain matter. The more material the radiation can pass through, the stronger the penetration power and the more dangerous. So as you can see, gamma is the most dangerous because it can pass through the most type of material. Alpha, on the other hand, has the weakest penetrating power. Ionizing power is the ability of radiation to damage molecules. How does it do that? When a radiation particle interacts with atoms, the interaction can cause the atom to lose electrons, thus becoming ionized. Check of understanding number 2, compare the types of radiation, which one's the biggest and which one's the smallest. Using the table, the biggest is alpha and the smallest is gamma. Check of understanding number 3, compare the types of radiation, which one has the largest magnitude of charge, which one has the smallest. Using the table, alpha has the largest magnitude. It is +2. The smallest will be gamma because it does not have a charge. Check of understanding number 4, which do you expect to have the greatest penetrating power? From the diagram before, gamma have the greatest penetrating power because it has no mass and no charge. Because it has no charge, it will not interact with surrounding molecules. Since gamma is small and does not interact with other molecules, it is easier for gamma to penetrate materials. Check of understanding number 5, which do you expect will have the greatest ionizing power? Alpha will have the greatest ionizing power because it has the highest charge. It will interact with the surrounding molecules. Penetrating power has an inverse relationship to ionizing power. The stronger the penetrating power, the weaker the ionizing power. So gamma is the strongest penetrating power, alpha is the weakest, but alpha has the strongest ionizing power, and gamma is the weakest. Beta particle and positron are in the middle. On the regions, make sure you know the order of strength of the penetrating power of the radiations. Learning check number 3. Which nuclear emission has the greatest mass and the least penetrating power? Pause the video and resume when completed. That'll be alpha particle, choice 1. Learning check number 4. Which list of particle is in order of increasing mass? Pause the video and resume when completed. Electron's the smallest, then is proton, then is alpha. Electron weighs 0, proton is 1, and alpha is 4. Choice 3. Learning check number 5. Which nuclear decay emission consists of energy only? Pause the video and resume when completed. Gamma radiation is pure energy, so choice 3. Here are some review questions. Question 1. A positron is sometimes referred to as a positive electron. Why would scientists call it by this name? Because it has the same size as an electron, but opposite charge. Question 2. Another name for alpha particle is a helium nucleus. Why would scientists call it by this name? because both have only 2 protons and 2 neutrons. Question 3. Which form of radiation is pure energy? That's gamma. Question 4. Given the mass number and atomic number for alpha particle, how many protons and neutrons are inside this particle? 2 each. Question 5. Which of the 3 types of radiation have the greatest mass? How do you know? It is the alpha particle because of the mass number, which is 4. Question 6. Which scientists use alpha particles to bombard gold atoms to discover information about the structure of the atom? That was Rutherford. Here we have a block that is a radioactive source that's releasing radiation, A, B, C. Next to the block are 2 charged plates, one negative and one positive. To figure out what each arrow can represent, we have to look at the direction of the arrow. Alpha particles are positive, therefore it will be attracted to the negatively charged plate. So arrow C can represent alpha particle. Beta particle is negative, therefore it will be attracted to the positive charged plate. So arrow A can represent the beta particle. Gamma radiation is neutral, therefore it will not be affected by the positive or negative charged plate, it will just go straight through. So arrow B can represent gamma radiation. Positron is a positively charged particle. It will be attracted to the negative charged plate, therefore arrow C can represent positron as well. Proton are positive. It will be attracted to the negatively charged plate as well, so arrow C can represent proton. Electrons are negative, and they'll be attracted to the positively charged plate, so arrow A can represent electron. Neutrons are neutral. They will not be attracted to positive or negative charged plate. It'll just go straight through, so arrow B will represent neutron. Learning check number 6. A radioactive source emits radiation which is deflected as shown in the diagram below. This radiation could be what? Pause the video and resume as completed. The path of the radiation is attracted to the positive electrode. Therefore, the radiation must be negative. So the answer is choice 1. For question 7a, you have to use table N to look up the decay mode or the type of radiation that is released from the radioisotope. Try to do this yourself. Pause the video and resume as completed. Here are the answers. Learning check number 7. Which 2 radioisotopes have the same decay mode? Pause the video and resume as completed. Using table N, the answer is choice 1. This concludes the video lesson. Remember to do the JunoPod homework.